All right, so we can derive some standard equations. Standard equations or relations. And what are these standard equations? We are just saying that when a body is thrown vertically upward, when it gets to the maximum height, what happens? When it gets to the maximum height, what happens? Yes.
It stops momentarily.
So it stops momentarily for a while and then returns. So when it gets to the maximum height, what really happens? Apart from stopping momentarily. Yes.
Acceleration becomes zero. Acceleration becomes zero.
Not acceleration.
Gravity pulls the object
Now
back.
Gravity acts on it.
Gravity
Yes,
pushes the object.
No, once it is going up, gravity is acting against it. Yes. But when it gets to the maximum height, something happens which you even said. One of you said it. Leonard.
Sir.
Okay, go ahead.
Final velocity becomes zero.
The final velocity becomes zero. This is how it is. You are giving it a velocity u, initial velocity u. Without this velocity, it cannot go up. Okay. Now, assuming this is 20, after changing time, maybe 1 second, this velocity will drop 19, 18, 17, 16, 15. Now, by the time it gets to the maximum height, the initial velocity has dropped to 0. So we say at the maximum height, the final velocity v is equal to 0. And who is responsible for this? Who is responsible for this? Gravity.
Gravity.
Force of gravity. That's okay. So at the maximum height, final velocity v is equal to 0. So if at the maximum height, v is equal to 0, okay, so practically if you pick a ball and then you kick it upward, hey, no matter how hard you kick it, it will not go to heaven. It will go and then get to a maximum height and come back, no matter how hard you hit it. When it gets to that maximum height, it is returning because its final velocity has reduced to 0. So it has no velocity to move further upward again, and so it must end. So at the maximum height, v is 0, then the body stops momentarily, meaning for a short while, and comes down. So at the maximum height, v is 0. If v is equal to 0 at the maximum height, then when you use equation 1, v is equal to...
This is semi-cool.
Hey, Leonard.
Can't you see how they are blue?
Leonard, mute yourself. When you pick equation 1, v is equal to u minus gt. At the maximum height, v is 0. So when you put 0 here, it means we have reached the maximum height. You have u minus gt. Yeah, Archie, help me make t the subject from this. Yeah, Archie. Hey, yeah. Okay, anybody to help me make t the subject here? Okay, Elizabeth. Elizabeth,
Please,
go ahead.
T is equal. Please, T is equal to U over G.
Good. So T is equal to U over G. And this is the quickest, fastest, I'm short of words, quickest and fastest relation to help you get time taking to reach the maximum height. So if you are in a question, if you are asked to calculate the time taken to reach the maximum height, it is simply T is equal to U over G, where U is the initial velocity or velocity of projection divided by the constant acceleration due to gravity. All right. So that is one standard formula. Then I want to have a formula for a maximum height, a standard or a known formula for the maximum height. There's one thing that I know, and that is when the body gets to the maximum height, its final velocity must be 0. So if the final velocity must be 0, then using equation 3, using v squared is equal to u squared minus 2gh. Oh, here v is the final velocity, u is the initial velocity or velocity of projection, g is the acceleration due to gravity, and h is the height traveled, vertical height traveled. So if v is equal to 0, then the body has gotten to the maximum height. When I make h the subject, I have the formula for the maximum height reached. So at the maximum height reached, the key point is that final velocity must be 0. Then, if I put 0 in place of v, squaring it is not necessary because v squared is the same as 0. And then I equate this to u squared minus 2gh. When I make h the subject, I have an equation for the maximum height reached. Help me make h the subject here. Help me make h the subject. Yes, Josiah. Josiah, go ahead. Oh, please, if your hand is up, go ahead and answer.
H is equal to U squared over 2G.
Okay, so h is equal to u squared over 2g. And this h is h maximum. So h maximum is equal to u squared over 2g. And this is the expression for the maximum height. So it means that in a question, when a body is projected vertically upwards, and I'm asked to calculate for the maximum height range, I just square the initial velocity and divide it by 2 times gravity. I have the maximum height. So another standard formula there. Please, any question? I can also get the same. I can also get the same formula, derive the same expression for the maximum height ratio. When I look at the second equation, the second equation is this: H is equal to UT minus half JT squared minus half GT squared. So if this is it, when I substitute the time taken to reach the maximum height, substitute T is equal to U over D into this relation. So let's do it together. Wherever I see T, I substitute U over D. So times U over D minus half G times U over D squared. What am I doing? I'm substituting the formula for the time taken to reach the maximum height. Let's simplify. This is U squared over J minus half J. I simplify what I have within the brackets, and that is U squared over J squared. The denominator J squared is actually J times G. So this is J times G. And this J can cancel one of the G's. So we have U squared on J minus U squared over 2G. U squared over J is common, so I can factorize that out. Okay, so when I factorize U squared over J out, I have 1 minus, what is left? I'm factorizing U squared over J out. 1 minus what? What is left here? I'm factorizing out U squared over G. So 1 minus what must be written here so that it gives me the same expression above. 1 minus what?
1 over 2.
Good.
1 over
Good or half. Good. And what is 1 minus half? What is 1 minus half?
half.
Good.
Half.
So when you remultiply, you have numerator by numerator, denominator by, you still have, you have U squared over 2G, which is the same relation for H mass. So you can obtain the same relation when you pick the second equation of quotient and substitute the time taken to reach the maximum height, and the value will be the same. Please, is that okay? Any question? All right. Today, I want us to go through the theory. Then, in our next meeting, we solve questions with it. So this is from all that we've derived, we are considering a body projected from the ground. If you are, maybe your option is standing on the ground, throws an object vertically upwards. This is what we are considering. Now, if Yaa is standing on something, on a tower, on a building, okay, what can also happen? Different things can happen. So let's look at the object projected from a height h above the ground. So this is the, if it's a tower cannot be built in air. So the tower is on the ground. So the height of the tower is h. Our relations we derived earlier, the object is being projected from the ground. Now the object is being projected from a height. So the body is here, and then maybe Leonard is here. Leonard throws an object vertically upwards. That is what we are looking at. Please, are you with me? Class, are you with me?
He's coming.
So the object is going up with an initial velocity u. Now, the different questions that can possibly be asked in this situation is that determine one, time taken to reach the maximum height. Determine the time taken to reach the maximum height. 2, determine the time of flight. Time of flight. 3, maximum height reached. Determine the maximum height reached from the ground. Determine the maximum height reached from the ground. Then, finally, the maximum height reached during the whole flight. The whole flight. So when an object is projected from a height above the ground, these are the possible questions that can be asked. Let's go through each one of them. Time taken to reach the maximum height. The body is thrown from a height. Okay, so over here is the same as the object being thrown from the ground. So the time taken to reach the maximum height will still be equal to T is equal to U over G. It will not change. Time taken to reach the maximum height. Then the time of flight. What we actually mean by the time of flight is that the object is being thrown from the top of the tower. The time taken to reach the maximum height plus the time taken to move from the maximum height to the ground is the time of flight. During the whole flight, when the object is thrown up, you will not be chasing it to catch, no. So when you throw it up, it will surely get to a maximum height and drop to the ground. So the time taken during the whole journey from when it was thrown to landing on the ground is the time of flight. Please, are we okay?
Yes.
So the time of flight, we mean the total time taken, okay, during the whole journey of flight of the body is what we mean by time of flight. So over here, for II, the time taken to reach the maximum height, which is, so the time of flight, capital T, would be equal to U over G. So time taken to move from here, assuming this is the maximum height, time taken to move from here to this point, it will move from that point to the same level again. So this will be 2, U over G again. So we more or less have 2 times, we have 2 times U over G. We have 2 times, Gabby, your hand is up.
Sir, please, I don't understand how you got the capital T.
Oh, capital T is the time of flight. So capital T is the time of flight.
Sir, please, doesn't mean that like that's the symbol denoted for time of flight.
Come again.
Like that is it that that's the symbol denoted for time
We
of
are
flight?
using, yeah, Gabby, we are using that to represent the time of flight. Is that okay?
Okay, sir. Okay.
So we are using capital T to represent the total time, which is the time of flight. All right. So time taking to move from here to this, time taking to move from the maximum height to that level, and then the time taking to cover the vertical height of the tower. So plus TH, where H means the time taken to cover this vertical height. Later, I'll show you how to calculate how we can determine TH. Is that okay? But the time of
Mr. Can you
ABR.
please take it again? Can you please
All
take
right.
it again?
So this is the object's journey. It will move from wherever it is thrown to the maximum height. Then it will move from the maximum height to the same level where the object was initially thrown. It will take the same time. So if it takes 2 seconds to move from this point to this point, it will also take 2 seconds to move from the maximum height to this level. So that is the reason why we have 2 times U over G. Or we can indicate this as 2T max. Let's represent the time taken to reach the maximum height by T max. So it will use 2T max to move from here, get to the maximum height, and then return to that level. Yeah, are you okay? Yeah, are you okay?
Yes, please.
Then
Yes,
from
please.
when the object moves and then come to this level, and because it is dropping on the ground, the time taken to cover this height of the tower H must also be added to this. So the time of flight will be 2t max plus th. Don't worry, we'll solve a question where you understand properly. Are we okay? Then 3. Maximum height raised from the ground. Maximum height raised from the ground. The maximum height raised from the ground. So over here, the object is being thrown from this level, from the top of the tower. Its maximum height raised. But we are told from the ground. So we will add the vertical height of the tower H. So maximum height raised from the ground will be equal to the object is being thrown from here. And this is the maximum height. But we are taking our measurement from the ground. So this will be equal to H max plus the height of the tower. Maximum height raised from the ground. When it is thrown here, this is the maximum height raised. But we are measuring this maximum height from the ground. So plus from here, from where it is thrown to where it will reach. This is H max. But we are taking our measurement from the ground. So H max plus the height of the tower becomes the maximum height raised from the ground, which technically would be equal to U squared over 2G plus H. Are we okay? Are we okay here?
Yes.
Hey, you are not talking. Are you asleep? And then the fourth one. Maximum height reached during the whole flight. During the whole flight. From when it was thrown, getting to the maximum height and dropping to the ground. Maximum height reached during the whole flight. When it was thrown, okay, falling from there to the ground. I want somebody to help me derive this relation. Maximum height reached during the whole flight. Yes, can somebody help me out here? Maximum height reached during the whole flight of the body. Okay, Gabby. Gabby, go ahead. Gabby, are you there? Oh, your hand is up, but you are not talking. Please, anybody to help? Mary, Audrey, Paulette, Angel,
Said, please, when you are finding all these in the question or the diagram, will they give us like what the, let's say, the values that we use to get these, or you need to find them yourself?
Gabby, don't worry. I will solve questions with you. So you know how to apply it, okay? We are today,
Okay,
we are
sir.
just going through the theory. So you don't worry. I'll look for questions to this effect and then we will solve. So you relax. How do we determine the
Okay,
maximum height range during the whole flight? Yes. Hey. Okay, maybe. No, let me call. Let me call. Let me come to your homes and then call you. Since you don't want to talk. Elizabeth, Elinam, Dodu, Della, I'm on you. Della, help me out with maximum height range during the whole flight. And the whole flight, this is what I mean.